Good morning, and welcome to MCMC's Summer 2016 webinar series entitled Performance Monitoring, Easy as Pie. I will be your presenter for today. My name is Gans Guzman. My email address and phone number are on the slide, as well as a link where we will actually post the slide presentation as well as the recording for this presentation. This URL will also be on the final slide, which will stay up till the end of the session, so you don't need to write it down now. Okay, so our agenda for today, we're going to discuss differences between the Pi platforms. We're going to look at preparing the Pi for the monitoring that we're proposing as part of this presentation. And we're also going to look at how we visualize the data that we collect with the Pi. And at the end, we'll talk about some deployment options. Also in there, when we go over the visualization of the data, we will also look at the an actual instance of the data visualization application, so that you get a chance to see what that looks like in real time. Okay, so all Pis are not created equally. As you can see there in the upper right-hand corner, that is what a Pi looks like. That particular one, I believe, is a Raspberry Pi 2. Just know that the 2 and the 3 look almost exactly the same. The only difference is on the 3, there's actually it actually has wireless, so you actually see a little nub for like an external antenna. But it also has wireless built onto the board as well, so you don't actually need an external antenna, but just know that that's what a 2 or 3 looks like. A Raspberry Pi 1 looks different from that. But if I was going to buy one today, I probably would be buying 3s because the price is pretty much the same across all those platforms. So the numbers that we have on this particular slide are based on tests that we did on the Pis with iPerf. To see what the maximum throughput we could actually get through these devices if we were actually using these for bandwidth or throughput testing. As you can see, the Raspberry Pi 1 on the upside, meaning transmitting, we got about 49 megs. On the receiving side, we got closer to 100. The Pi 1, 2, and 3 all have a 100 megabit interface on them. The Raspberry Pi Pro, or the Banana Pi Pro, actually has a 1 gig interface on it, and you can see that we get numbers closer to a gig with the iPerf testing. One thing that people have mentioned to me is like, well, the Raspberry Pi does have a USB interface on it, so couldn't we just put in a 1 gig Ethernet adapter on the USB interface and get numbers closer to a gig? Well, the answer is not really, and the reason being is that all these Pis use USB 2.0. and the max data throughput on the USB bus is 480 megabits per second. And that's in a perfect world, right? We never see numbers like that in the wild. So as I mentioned earlier, the Raspberry Pi 3 and the Banana Pro both have wireless built into the modules. With the Banana Pi Pro, it actually requires an external antenna, which comes with the Pro. The Raspberry Pi 3 does not require an external antenna, but it has a little nub so you could actually attach an external antenna to it. So the both of these platforms utilize 802.11n only in the 2.4 gigahertz range, right? It's good to mention because, I mean, if you want to do 5 gig testing, you would actually have to use a 5 gig wireless dongle that you would use via the USB port. Once again, you still run into that same USB bus limitation of 480 megs. I've got some numbers up here for the theoretical limit for N at 2.5, or I'm sorry, at 5 gigs, which is around 600 megs, and for 2.4 at 300 megs. These, once again, perfect world. You're never going to see these numbers in the wild. More realistically, what you're probably going to see is about 300 megs on the 5 gig and about 144 megs on the 2.4. So just be aware, if you're going to be using wireless on these guys to do any throughput testing, these are going to be your limitations. Okay, so the proposal of this project is to be able to do some very high-level performance monitoring with a Raspberry Pi. We're going to start with a plain Jane Raspberry a Raspbian image, right? It can be downloaded from raspberrypi.org. The documentation on how to install the image is available on their website. I am not going to go through how to do this because, once again, they did a very good job of explaining how to get the image, how to burn the image onto the card, and power up the Pi. Okay. Now, once you do power up the Pi, it's going to basically bring you to a prompt for username and password. The default username is going to be Pi. The default password is going to be Raspberry. Once you actually log into the device, you're going to want to do some changes. And the easiest way to make these changes is using the configuration utility that is provided by Raspbian, which is the raspi config. There are three things you're going to want to do in that configuration utility. You're going to want to expand the file system. You're going to want to change the password to something other than Raspberry, and you want to set the time zone. So this is basically what that tool looks like when you actually run it. This was done via the HDMI cable, so it's more of a sort of colored GUI looking thing. If you do this over SSH, it's going to be very similar, but it's just going to be black and white. And as I mentioned before, expand file system. You're going to basically just select one, hit select. It's going to go ahead, it's going to expand the file system. Once it's done, it's going to ask you to reboot. But you're going to want to hold off on rebooting until you've done the other two steps. As I mentioned earlier, changing that password. Do not leave that password as Raspberry. Okay? And then setting the time zone. Once you've done those two things, and the time zone will be found under option 4, once you've done those three things, then you're going to go on ahead and hit finish, and at that point it's going to ask you to reboot. So once the Pi finishes rebooting, it comes back, you're back at the prompt, you're going to put in Pi as the user again, you're going to put in whatever password you chose, and then you're going to want to go ahead and update the operating system. In Debian, it is a two-step process. First thing you need to do is sudo apt-get update. This is going to update the repos in that operating system, and then once that's finished, then you're going to want to do an apt-get upgrade. The -y is so that you don't have to answer the prompt, because what it's going to do is it's going to go out and it's going to run a check to see what packages are installed and what packages are available for upgrade, and then it's going to ask you, do you want to do this? Because we ran this, we do want to do this, so we use the -y flag to basically go ahead and answer that prompt for us so that it does it automatically. Okay, so once it's upgraded, we can go ahead and install the first package we're going to be using. So as I mentioned before, basically we're configuring these Pis to do some metrics collection for performance. Okay, how we're going to store these metrics is on the Pi itself with a application called Influx DB. Influx DB is a database for storing time-based metrics. It's very efficient at doing this. It's got a pretty small footprint, so it's ideal for a Raspberry Pi. So, and as we go along, I'll talk about why we decided to go with this approach. But just know that InfluxDB is the database that we've chosen for storing the data for these metrics. The InfluxDB company, application provider, whatever you want to call them, actually have a binary file for the ARM HF, which is the architecture of the processor on a Raspberry Pi and a Banana Pro Pi. Also, there's an Orange Pi out there, which to me, I don't know why. I couldn't see any reason why there was an Orange Pi, because it didn't seem like it was any better than anything that was already out there. So usually when they create a new version of a Pi, it's usually they're trying to do something different, and in this case, the Orange Pi just didn't fit the bill. But as I said, go ahead and download that binary package from the Influx website at that URL. Once you have it on the Pi, you're going to want to go ahead and install that package, and there's the command line to do that. And then you're also going to want to install another package once that is done, which will basically just come out of the distro. Okay, so now we have InfluxDB installed on there. We're going to install the next package that we're going to use, which is collectd. Collectd basically is a collection of utilities for various plugins that are available within this package. So once again, we're going to do a sudo apt-get install -y, so we don't have to answer the prompt, collect D, and the collect D utilities. This is going to go ahead and install those 2 packages and then get us ready for the next step, which is going to be to configure Influx DB to work with collect D. Okay. The configuration file for Influx DB is located at that file location there, which is /etc/influxdb/influxdb.conf. To edit this file, you're going to have to do a sudo vi, or if you're a nano user, you could do sudo nano. I am not a nano user, so I probably won't talk nano very much. But just be aware that whatever your chosen method of modifying or editing files, it's completely up to you. I use VI because that's what I'm comfortable with. Okay. So once you actually open up that file for editing, you're going to want to look for declaration for collect D. I would basically just do a find, which is basically in VI, it's a /, and then you would type in collect D and then hit enter, and it will basically go through the file and look for that word in that file. Once you find the declaration for collect D, you're going to want to add the following lines. Enable equals true, bind address equals localhost :8096, database equals collect D. It could be something else if you want it to. Collect D, it just makes sense to me, so that's what I used. And then the type DB equals /user/share/collect D/types DB. This is all you really need in this file. So at that point, we would go ahead and do escape to exit editing. You would do a :WQ, so right quit, and I always like to add the exclamation point after that. The reason being, if the file is open and actually being read, it won't allow you to write to it, but the exclamation point basically just tells it to write it anyways. So I always follow that practice of doing a right quit exclamation just to get that file to write out. Once that file is written out, then you're going to go on ahead and start the Influx DB service. The newest version of Debian uses system control, just like Red Hat 7 does. So the command for that is going to be sudo system control start Influx DB. Now, because we don't want to have to start this service every time we reboot, we also want to go ahead and enable a service so that it starts automatically. The command for that is sudo system control enable Influx DB. Okay, so once that's running, we're going to want to go ahead and create a database for our collect D so that it gets so it has a place to put that data. There are a lot of different ways to do this. This is probably the easiest way. We basically just use a curl command. So we're going to go curl-post http://localhost port 8086, which is the port that InfluxDB is listening on, /query, and then --data -URL encode double quotes q equals create database, the name of the database we want to create, double quote. And at that point, this command will create the database in InfluxDB, and then we're ready for the next step. So now we're going to go ahead and we're going to configure collect D. Once again, the configuration file for collect D is in /collectd/collectd.conf. I'm going to use VI again, and just know that if you forget to put sudo and you go ahead and make these configurations and you go to save the file, it will tell you you can't save the file because you don't have permissions to write to the file. So always make sure that you use sudo. You elevate your privileges or elevate the privileges of the user Pi, right, so that you can actually save your changes to these files. It's kind of a pain when you go through a really lengthy change in a file and then you realize you can't save it. So once again, I'm going to use a find, right? I'm going to look for something. What I'm looking for is in the global settings, which is really near the top of the config file. So you really could just arrow down and find these entries. What we want to do is we want to remove the pound sign, which is basically a comment, right? So we're removing the comment from these lines so that we can enable these parameters. Okay, so we're going to enable the base directory for collect D, we're going to enable the plugin directory for collect D, and we're going to enable the database types again. Okay. Then we're going to want to look for the declaration for the interval. The default interval within collect D is 10 seconds. I could tell you that some of the tests that we're going to run, If you ran these every 10 seconds, you probably would upset some of your providers. So I went ahead and changed that value to 300, which is basically every 5 minutes, which is more acceptable. So just know that I recommend 300. You could leave it at 10 seconds if you want to. More than likely, you'll probably start getting blocks from the sites. 5 minutes, like I said, is pretty acceptable. So I would recommend 300, but you can make that anything you want to. But I wouldn't make it less than 10 seconds, that's for sure. Okay, so some other options we're going to want to enable within this file, and these are under the plugins directives. We're going to want to enable curl. We're going to want to enable interface. We're going to want to enable network, and we're going to want to enable ping. Just know that there is a huge laundry list of plugins within CollectD, and some of them are enabled by default, like CPU, DF, battery. I don't know why, but you could go back and disable some of these if you're not intending on using them, especially battery, because you'll never use that on a Raspberry Pi. But these are the 4 that we are concerned with, at least for the purposes of what we're trying to do here. So how do you enable it? Once again, you just remove the pound sign from in front of these statements. And this is all in the same, all these configurations are being all done in that same file, so it's best to go ahead and do them all at the same time. So now we're going to want to go ahead and actually configure the plugin for curl. So if you do a find again, find the plugin curl, you're going to want to remove the pounds from the beginning of the directive and at the end of the directive. So the beginning of the directive is going to be plugin curl, and then the end of that directive is actually going to be /plugin. Right? Don't worry about anything else that's in that directive because we're not going to use any of it. We're actually going to add the pieces that we want to use. And in this case, this example shows you how you add an option for Google. Okay, so as you can see in that example, you got less than page, double quotes, Google, double quotes, greater than. That is basically just giving it a name so we can identify this when it's in the database. Okay, the URL that we want to run the test against, what values we want to get out of that, which is a response time and the response code. We're going to set those to true, and then we're going to close that page with a /page. Just know that you can create as many of these as you want to. And when we get to the demo part of this, you're going to see that I have probably about 5 or 6 of these in there. You can basically just stack them one after another. They just have to make sure that they end up between the plugin curl and the /plugin, which is the end of that directive, okay? But once again, you can add as many of these as you want, but for this example, I'm just showing you one. But they're all going to basically look the same, right? They're all going to have a name, a page name, and they're all going to have a URL associated with that page name. So now we need to go ahead and configure the plugin interface. Once again, we're going to move the pound signs to enable the declaration. In this one, this was a really short one, so I went ahead and put the whole declaration in there. As you can see, it's plugin interface, ignore select false, and then the close of that plugin. Something to mention here, if you're going to use an interface other than each0, you're going to want to make sure that you define that interface here, right? By default, each0 is going to be selected because it's generally the first interface found on the operating system. But if you're going to use a wireless interface or something like that, make sure that interface reflects the interface that you're actually using. Okay? So then we're going to go ahead and we're going to configure the next plugin. As I said, there were 4 that we were concerned about. The next one being networking or network, right? We're going to go ahead and remove the pound signs for the declarations. And this is basically configuring CollectD to talk to Influx DB. Okay, so we're going to basically add this declaration or add a statement in that declaration, which is going to be server localhost because the Influx DB is running on the same host, and then the port that service is listening on. Okay, which is 8096. Okay, and then the last plugin, as I mentioned earlier, was ping. We're going to go ahead and do the same thing here as well. We're going to go ahead and find this plugin. We're going to go ahead and remove the pound signs from the beginning of the declaration, at the end of the declaration, and then we're going to add some statements to this declaration. This one is actually really simple. All it is host and then some value. The first one there would be, let's say you wanted to ping a device on your network, like the core router or maybe the router, you know, somewhere else. That's what that would look like. You would just basically say host, double quote, IP address, double quote. If you're going to ping it by host name, it would be by the host name of that device. If you're going to ping a website, it would be the URL for that website. Those three conventions are the only things that are accepted by this plugin. And you'll see how we use this later on, but we were basically just set up ping to a website so that we can measure latency over time to that website. And this is the rest of that, the rest of the statements in that declaration. So I was saying plugin ping, the interval, we can go ahead and set it here once again. We're going to set it to 300 seconds, which is 5 minutes. We're going to set the timeout for that plugin. We're going to set the time to live. We're going to define what device we're using. Once again, each 0, and then max miss -1. Okay. And these statements are already in there. So all you're basically doing is just removing the pound sign, which basically enables those functions within that directive. So we have it all configured. We went ahead and we saved that configuration changes using right quit. Well, escape : right quit for VI. If you're using Nano, you know better. Then once we have those changes saved, we're going to go ahead and we're going to start that service, make sure that it comes up, and so hopefully we didn't have any errors in our file, right? So at this point it will start up, and then once it's started, we're going to want to go ahead and enable that service so that we don't have to restart every time the machine reboots. Okay, so at this point we have Influx DB running, we have collect D running, and it's running those tests every 5 minutes, and it's collecting those metrics and it's putting it into the Influx DB. So at this point you would think, well, I'm done, it's working. Well, you always have to consider security, right? This is a device like any other device that can be abused because it's on your network, right? It's running Linux. If someone can get on it, they can definitely abuse it. So we're going to want to go ahead and secure this, and we're going to use IPtables to do this. But the thing is, with Debian, IPtables is not persistent, not like you would find with a Red Hat distribution. So in order to make IPtables persistent, you actually have to install another package. And lo and behold, they called it IPtables Persistent. Makes sense. So once again, sudo apt-get install -y IPtables -persistent. This is going to go ahead and install that package, and this package installs pretty quickly. Now, once you actually have this package installed, anytime you make changes to your IPtables, you're going to need to run this command in order to save those changes to a persistent file, which that file is actually named v.4, I believe, which basically is going to be in a path that's going to be like /etc/IPtables/vi4. Just know that anytime you make changes, you're always going to want to go ahead and save your changes, because if you don't, you're going to lose them all, right? That was the whole reason why we installed this package to start with, because before, what would end up happening is you would actually create a file called IPtables, and every time you rebooted the machine, you actually had to run a command to reload that file into your IPtables. It was kind of a pain. This definitely solves that and makes it a lot easier. But if you forget to save your changes, whatever your last change is, what's going to end up in your IPtables. So this is an example of an IPtables that I went ahead and put together. The first 3 statements are pretty standard. You see those everywhere. I went ahead and added some rules for SSH. So I'm locking it down to some particular networks. You could lock it down to a subnet, like maybe your management subnet, or you can lock it down to specific machines if you wanted to. It's up to you how you manage security on your device. But I do recommend that you do some security on this device, because there are some ports that are going to be listening all the time, such as 22. Someone can do a brute force against the device against SSH and maybe take down take down the machine. You would say, okay, what's the big deal? It's just collecting metrics. It's no big deal, right? Unless you go to look at those metrics and they're not there, right? That's when it becomes a big deal. All right, so just be aware that doing security on your Raspberry Pi is highly recommended. And like I said, this is those first three are ports that are actually listening on the Raspberry Pi. And then the last one, basically, I'm just dropping everything. Well, technically, I'm just dropping everything above between 1 and 8088. The reason why I do it this way is you could actually say drop everything, but when you do that, it tends to make it a bigger target because then people are wondering why you're dropping everything. Whereas if you're dropping very specific ports, it makes it less of a target, right? And then those last two lines are essentially pretty standard across the board on IPtables configuration. Okay, so we've got Influx DB running. We got collect D running. We're collecting metrics based on some curl commands. We're collecting metrics based on some ping commands. So we're collecting latency to a device, and we're collecting actual GET requests from websites. Okay, so how do we visualize this data? You could use Influx DB to visualize the data. It's very ugly. It's just a bunch of lines of numbers that really wouldn't make sense to anybody, unless you have a head for numbers. So Grafana is the package that we've decided to use for visualizing this data. Why did we choose Grafana? Well, two reasons. One, Grafana is really good at visualizing time-based data, which is what we're storing in InfluxDB anyways, and it's free, right? Those are always two good reasons. Free is always a good reason to use something, right? Just like InfluxDB is free, just like CollectD is free, just like Raspbian is free. The only thing that costs is the actual platform to run the operating system, okay? And I did want to kind of take a step back. I forgot to mention this earlier, right? The Raspberry Pi itself is about $35, right? A Banana Pro is a little bit more than 50 bucks. But once you throw in, an SD card, a power supply, you're probably looking at, for a Raspberry Pi, I think a power supply costs about $7. A SD card, for an 8 gig SD card, you're probably looking at, maybe about $10 or $11. So it's not a huge investment, to go ahead and get this going, at least in a trial version, to figure out whether or not it makes sense for you, right? But back to Grafana. Currently, the latest version is 3.4.0. They do have a 3.1, which is currently in beta. I never recommend beta ever, unless you like pain. The URL there is where you can download it. That second URL is where there are directions on how to install it. And the reason why I didn't go through the process of installing this, because there's actually 3 versions of Grafana. There is a version for Debian. There is a binary for Red Hat / CentOS / Fedora. And there is a binary for Windows. I have not tested the Windows binary. I don't recommend running it in Windows unless you really have to. I recommend you run it in either Debian or in Red Hat or CentOS, which is free, right? Once again, free, keyword, free. Right, once you have this up and running, which, like I said, it's pretty easy to get it installed. There's not much to it. And the configuration for it is actually web-based, right? You're going to go ahead and start the service. And actually, after you're done installing, it will tell you how to start the service. It'll actually tell you at the end, to start server, run this command. And depending on the operating system that you've installed it on, will depend on how you actually start it, right? This particular package actually comes with 2 start files. They have system control start file, and they also have a initd start file, right? So you could either do service Grafana-server start, or you could do system control Grafana-server or start Grafana-server. So like the installation instructions, when you choose the particular binary that you're going to install, it's going to give you the specific instructions on how to get this installed and get it started. Once you actually have it started, once it actually starts, it actually will tell you once again, it'll give you a prompt. It'll say, now connect to IP address / IP address : port. which is going to be 3000. It's going to run on port 3000. Reasons why we're not installing this on the Pi. Yeah, forgot to mention that as well. Is this particular package does not have a binary for the ARM HF architecture. You can try to compile it for ARM HF architecture. I tried to compile it. In order to compile it, you got to use Go. In order to compile Go on a Raspberry Pi, takes forever. And then trying to compile Grafana on top of that was another, endurance race that I just, at the end, I decided it didn't make sense anyways, because really the visualization should not be running on the Pi. It should be running somewhere else, right? Because the data is actually being collected on the Pi. It's persistent on the Pi as long as the Pi is up, right? And then you would access that data from somewhere else. Grafana can be installed as a VM somewhere. It could be installed on a physical server. I'll show you an instance here running in a little bit. It's actually running in a VM, and it doesn't really require a lot of resources. So that was the reason why we decided it didn't make sense to actually have the visualization software running on the Pi along with the collection. Okay, once you have Grafana installed, you're going to want to go ahead and create a data source for Influx DB, which I'll show you how easy this is to do once we actually look at the instance. But directions on how to do this are located at that URL. And I also went ahead and said, make sure you use the data source Influx DB. Now, before 3.0, it would actually have two data source types for Influx DB. It actually had like an 8.x and a 9.x. The reason being is that it interacted with those two databases differently. But that has actually been pared down to one because they're actually dropping support for 8.x on Grafana, and the version of Influx DB that we're currently using is actually like 13.x. So I guess they just decided it didn't make sense to start adding more x's in there. So they just basically pared it down to one, because from 9 to 13, it basically interacts with that database the exact same way. So this is basically what the UI is going to look like. As I said, we're going to go ahead and we're going to pop out of here, and we're actually going to look at this, a live version of this. It's actually making some measurements, but this is essentially what it could look like. Okay, so this is my live instance of Grafana. Let's go ahead and take a look at the data source real quick first. So as I said, you would create a data source, and the instructions are going to look just like this. It's a little bit different in this particular version because this is a newer version of Grafana. But essentially, this is what a data source looks like. So you would click on Add Data Source. You would select the type of data source you're looking to add. In this case, it would be Influx DB. You would give it a name, right? Especially in this case, if you're going to be visualizing multiple instances of Influx DB on multiple Pis out there in your network. The URL, which is basically going to be the IP address, and then this port 8061. I'm sorry, yeah. And then the name of the database, which was collectd, right? Username and password. The default username and password is root. But you could configure a different password if you want. It has to be done within the Influx DB configuration. Just know that for this particular presentation, we didn't go that deep into it, just to kind of get this up and running. And really securing the database itself, if you're actually using IPtables to actually limit the access to that device, really the data that's stored in this database, like I said, it's just basically strings of numbers. It doesn't have any intrinsic value other than for the purposes it's intended, right? So really having a password on this database doesn't really matter. Okay, and then you would add that that data source, and you'd be ready to go ahead and start visualizing the data, because the data is already being collected, right? It's being collected on the Pis themselves. You're not actually collecting the data in Grafana. All you're doing is basically just attaching to that data and then visualizing it. So as I said, okay, this is my dashboard. This is the data. I actually have a retention policy on my Influx DB databases of 30 days because I figure after 30 days, this data is pretty much irrelevant. So you could, I think the default policy on there is never delete the data. I basically have it to overwrite the data every 30 days. And it's pretty easy to configure a retention policy. The directions to do that are available on the Influx DB website. It's not really difficult to do. But if you need assistance with that, definitely you can let us know, and we can help you with that. So I can go in here and I could say, show me the last 30 minutes. Remember, we're actually querying the data every 5 minutes, so looking at the last 5 minutes may not be very useful. I can look at the last 7 days. I could also go into a graph and select a time frame. And it will basically zoom into that time frame as well. Okay. You could, let me go ahead and reset this. Last 12 hours. Within the graph, you could actually enable or disable parts of the data being displayed. So let's say I just want to look at this Google accounts.google. This is actually accounts.google.com because I want to see how long it takes that page to respond. And these are curl responses. And as you can see, this is actually one Raspberry Pi. This is a different Raspberry Pi, right? So if I wanted to see Google accounts on that Raspberry Pi, I could do that. So you can see that there's a difference in the response times between these two Raspberry Pis. And part of that has to do with how they're located on the network. Okay. And you could actually create graphs that actually have both, right? So here I have one that basically is just looking at response times from both of them very specifically for just Google stuff. So I'm looking at just Google from Raspberry Pi 1, Google from Raspberry Pi 2, and that's www.google.com and accounts.google.com from both of those Pis as well. So what data you actually display is really up to you. What is it that's useful to you? How would you display this data so that it makes sense to you? All these graphs basically are the same. The only difference is how I chose to display the data. And if I wanted to go ahead and set this back, I basically just uncheck these and it turns it all back on. So these first two are basically just looking at curl times for those two specific Pis. This one here, for whatever reason, someone told me, well, maybe it would be nice to have a graph that didn't actually have all these values. Well, you could do that if you wanted to. You could just basically just have the lines, and you could do the same thing. You click on a line and actually bring up that data. And if you actually scroll through here, through the line, it will actually tell you what that data point is. You can see this is half a second. That's 1.56 seconds. So by scrolling along these lines, you could see what the data points are. And these are going to be every 5 minutes, right? So you don't have to have these values presented all the time unless that's more useful to you, okay? And as I was saying before, I have one that's actually doing pings. So here I'm pinging Yahoo from one Pi and pinging Yahoo from another Pi. And you can see once again, there are differences depending on where they are in the network. Now this may be, okay. Just know that the differences in the values between curl and ping, curl metrics are done in seconds, whereas ping latency metrics are done in milliseconds. So there is a difference, right? So just be aware of that when you're actually setting these things up, because you actually have to define how you're going to look at these values. And we'll go ahead and we'll look at that here in a second. So like I said, this could be okay. If we're looking at this here, this is what, 63 milliseconds from Pi 2 and 37 milliseconds from Pi 1. This could be normal for that network. But without actually having data, it's kind of hard to say, right? Now, if I take this and I look down here, and most of the time you can see these are a little bit lower, right? So that would be an anomaly to me. The question is why? Has something changed? I'm going to tell you more than likely, nothing has changed in that 5-minute time span. Other than maybe that server was just too busy to respond to my ping request, and so it waited a little bit longer to respond. That's very possible, right? But once again, without having data to back that up, it's kind of hard to say. And then you could also have sort of these kind of like status boards, right? Here I have one that basically is just showing the response time for MSN, showing the response code for Google, showing the response code for the NCN Cloud IDP. All the responses are 200. I actually have these configured so that the response is something other than or greater than a certain value. In this case, I have it configured so anything from 200 to 300, well, 299 is green. From 300 to 399 is yellow, and then from 400 and above, it's red. So if I were to get a response code of 500, this would actually turn red to let you know that that's probably out of spec. Or if you got a 404 or something like that, right? Here, once again, sort of visualizing those response times, just know that this is the actual current response time, not any of the other values. And the way I configured these was that if it was greater than, let's go ahead and take a look. If it's greater than 25 milliseconds, it's going to be yellow or orange in this case. And if it's greater than 30 milliseconds, it's going to be red. But anything less than 25 milliseconds would be green. You can configure these to whatever makes sense. Once again, these are just somewhat arbitrary values because I just wanted to make this turn red, essentially. This could be fine, once again, for this particular website. As you can see, when we were looking at this earlier, Yahoo does tend to have longer response times because, once again, like I said, it could just be that the database is busy, right? But without having a record of that data, it's kind of hard to be able to quantify those returns. So how easy is it to go ahead and add a graph? You go to here, add panel, graph, select your data source. In this case, it could be Raspberry Pi 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you wanted to do a group one with multiple ones in there, you select mix. So let's go ahead and we'll do a mix one right now. Then we're going to go ahead and add a query for Raspberry Pi 1. I'm going to select a metric, curl. I'm going to select a value. So as I was saying before, remember these were those names that we gave to those pages when we did the curl plugin configuration. So I could go ahead and select one, and then I want to go ahead and select the type. And in this case, it's going to be response time. Okay, so that's how easy it is to add a data point to this graph, right? I did that. Now I'm going to want to name this, right? So in this case, because this was Raspberry Pi 1, I could put in, RASP 1, and because it's the NCED Cloud, I'm gonna go NCED Cloud. So that way, when I'm looking at this data point, I can tell what it is, right? Otherwise, it basically just throws a generic name up there, as in this case, you could see it's just this curl value dot mean. Okay, so now if I actually go ahead and look at this, it's going to be all the way down at the bottom. I have this data point, which is the yellow line, which is this. Now this here is actually an artifact, and I'll go back in there and actually remove it. when you first start a query, it always adds a line, and as you can see, this one actually what added that default one that was in there was that Grafana one. So I'll go in here and I'll delete that line, and you can see that now I only see the data point for the NCI Cloud. Now, if I wanted to change the title of this panel, I would do that here. Change the panel name. If I wanted to change the values, meaning how wide that panel is, I can change it here as well. Remember how I was saying that you want to set your time metric for the axis here. This is where you would do that. So it'd be time, and because this is curl, this is going to be in seconds. So that way those values make sense when you're looking at them. You don't have to change the Y because, or the lower one, because that's always going to be the time base, right? Also, if you want to make some other changes here, like where we had the table, right? We can go ahead and add the table. We can go ahead and put it to the right. We could add the values, min, max, average, current. These are all values that are actually being stored in Influx DB as part of the test, right? So you see how easy it is to add a graph within Grafana. And, you know, really, it's up to you as to what is of interest. I will tell you that I actually have some graphs in here that actually do some uptime monitoring for the Raspberry Pis. I tried to get some other useful information out of the Raspberry Pis, but right now the CPU graph, at least the way it's being collected by CollectD, does not do percents. It does GIFs, which aren't really as useful. There actually is supposed to be an update to CollectD that's going to give you the ability to do percent of usage, which will be a lot more useful. And at that point, having a CPU graph of your Raspberry Pi would be useful, because then you could see what it's doing, whether or not it's actually being overtaxed or if something's going on, right? But for now, the only one that I've actually found useful, as I said before, I'm not going to save that, is basically I have some uptime monitoring that's going on. If I can get my graph to open. Interesting. They were there yesterday. gotta love live demos. But there were two graphs in it that actually gave me the uptime for each one of the Raspberry Pis, which is interesting. But we'll go back to this. As you can see, I have a bunch of other stuff in there. I'm not going to go ahead and display that now because it's just maybe that was just an anomaly. Let's see. Ah, there we go. There are my uptime graphs. It just wasn't refreshing properly. So you can see at one point these were up for 30 days. The reason why they were up for 30 days is because I was trying to make sure that these were going to work properly. So actually they were up for longer than 30 days. I actually had them up for about 2 months. I went ahead and took them down and then brought them back up before this presentation just so that I could have some data to look at. But right now, as you can see, it's just been up just a little over 3 weeks, and this one, you know, less than 3 weeks. Okay. Okay. So as I said, the Grafana visualization package is actually somewhat flexible, depending on the data that you're actually you're collecting with CollectD. There are other plugins in CollectD, but as I mentioned, for this particular project, these were the ones that made the most sense. As I said, curl time will tell you how long a website is taking to respond. Ping times would give you latency measurements, right? For websites, as you can see, probably not as useful, but definitely if you were pinging devices on your network. So if you were pinging the core router from an MDF at a school, that data may be more useful than actually pinging a website. The reason why I was pinging the website is I just wanted to see what it looked like, right? curiosity. So, and if that website is busy, it may not respond to the ping, right? That said, if the switch is busy, it may not respond to a ping, right? Because pings are not high priorities for these devices. So those numbers could vary depending on how highly utilized that device is. Okay, so just be aware of that with the ping response. But the curl time responses definitely are valuable. Just know that these curl time responses are actual total time. I'm actually going to show you how you could actually get some more deeper, I guess, information out of a curl command here when we talk about some extra tools. Okay, so let's talk about some deployment options. How do I foresee a site getting use out of this deployment, right? You could have a monitoring point, right, a Raspberry Pi at each MDF at each school, and then one at the core, right? So the core being closest to the internet, the MDF at the school being further away from the internet, right? What is the value of this data? Well, if you're getting really good return times from the core, but you're getting really bad return times from the MDF at that school, it could be an issue in the WAN, right? That's how you quantify this, right? Or let's say there's a school that has a classroom where the teacher's always complaining about wireless performance, right? You could take a Pi, configure it to use the wireless interface, set it in the classroom, leave it there for a week, and collect data. And if you're not seeing a problem, then more than likely it's not the connection, right? But it could be something else, right? It could be DHCP lease times. It could be just congestion in general, right? When you look at that access point in that room, it could be more than 25 devices contending for throughput on that access point. But at least now you could say that it's not necessarily the internet, as they would say. The internet is broken or the internet is down, when really the issue is not the internet. The issue is how you connect to the internet, right? And as I was saying, there are actually some tools that you could run on a Raspberry Pi to get some more data to quantify what's going on. And the first one we're going to look at is curl, right? Since we're using this to collect these metrics, right? Why not use curl to get some deeper metrics out of it? And that particular command line is going to produce that output that you see underneath that command line. This is run from the Raspberry Pi. And these are the metrics. As I said, remember when we were graphing, we're actually graphing total time. We're not graphing all these other parameters, but all these other parameters feed into the total time, right? So that first parameter, lookup, is how long it takes DNS to resolve the URL that we're curling to, right? Curl basically acts just like a browser, whereas different from wget. Wget does not act like a browser, so it would not return the same values, okay? So as I said, that first value there is how long did it take curl or the Raspberry Pi to resolve google.com, okay? That second metric there is how long did it take for the TCP handshake to finish, right? And these numbers are cumulative, right? So just be aware of that, right? Okay, the app connection value there is if there was any SSL involved, how long did it take for that SSL handshake to actually happen? So, you get the server says hello, the client says hello, and they agree that this is a certificate they're going to use to encrypt the traffic, right? That's what that app connect time would be. And in this case, there wasn't any, so there isn't any. The prefetch is how long did it take for that first byte of data to start being transmitted. That's the pre-transfer. And as you can see, that and the connect are exactly the same. So it didn't really take any time at all, right? The redirect, and I did this on purpose, if you go to google.com, that actually redirects to www.google.com, right? Had I put www.google.com in there, there would be nothing in the redirect because there wouldn't have been a redirect, right? But if you start to see really high redirect numbers, then there's probably something going on with that host that you're talking to, right? Because they shouldn't be redirecting a lot, right? Those numbers should not be really high. The start transfer is how long did it take for that first byte of data to actually be received, right? And then again, the total time is how long the whole process took for the page to load and everything, right? And that's what I was saying. These are all cumulative, right? So they're actually all adding into each other as they go down the stack. Okay, so just be aware of that too. So that's curl. Like I said, very useful. There's a lot of data that can be extracted from curl. Curl could also be used to pass along data, as in like a username and password and things like that. So there, you could actually use it to log into a web page or an application and be able to get these metrics for that interaction. Okay, so like I said, a deeper dive than what you would get from just the metrics that we're collecting on a daily basis, right? So if you think there's an issue with that site, you could actually run this curl command to get more in-depth data. MTR. So MTR is a way of looking to see how many hops there are between you and the endpoint that you're trying to get to. In this case, we used Google again as an example, right? You could see that there were 5 hops to Google, right? And really, we're more or less just concerned with the average number, right? Because that's going to be the most significant value in there, right? So you can see there was 5 hops, and the last one being the server that responded for www.google.com, right? If you're seeing a lot of hops, so let's say you ran this today, and sometimes some of these tools, like especially like MTR, you almost kind of need to run it ahead of time, right? So that you actually have some sort of baseline to say, okay, it's 5 hops, right? And then people start complaining about issues, and you run MTR, and you see now there's 10 hops or there's 12 hops. What changed? You know, MTR is more useful for what changed more than what the data that's actually being represented here, right? Because as you can see, the average here, if we look at this, for the most part, the first 2 was about 1.2 seconds. I'm sorry, 1.2 milliseconds. That's not in seconds, it's milliseconds, right? That third hop was 5.6 milliseconds. The hop after that, 7.6, and then the hop after that, 7.1. So you can see that in this case, once it sort of left the NCRIN network, the hops started to grow, right? So like I said, really the relevance of this command is how many hops does it take me to get to the destination, right? Like the old commercial, how many licks does it take to get to the center of the Tootsie Roll Pop, right? How many hops did it take me to get there, right? And if today it takes 5 hops and tomorrow it takes 15 hops, what has changed to make that happen, right? So once again, more data to quantify what's going on. And the last tool that we're going to look at is IPerf. Now remember, as I was saying, right, you have the limitations on the Pis 1 through 3 of 100 megs. In the Banana Pi Pro, it's a gig, but it's not a complete gig, but it's close to a gig, right? And if you happen to use a USB adapter, 480 is that limitation again. These 3 tests are tests that I use quite often. Just know that first test, it's actually a UDP test, which is denoted by that -U. The other 2 tests were TCP tests. The first one, I'm basically just saturating the pipe up to 100 meg. The second one, I'm transferring a gig of data to see how long it takes. And then the third one, I'm basically doing a recursive test. So, and then with the recursive test, there's 2 flags. There's either a -D or a -R. Either one of them will get you a bidirectional test. I think -D is actually bidirectional and -R is recursive, but both of them basically give you the exact same data. So it doesn't matter which switch you use, both of them will give you the same data. Okay. And like I said, this is something that you could play with. Just know that these are destructive tests. So this is kind of sort of like the last resort to trying to get to the problem or the issue that's happening. And know that UDP and TCP act differently on the wire. Okay, which is the reason why you want to run these different kinds of tests to see what's going on. So that's the end of the presentation. As I said, the presentation and the recording of this presentation will be available at the URL at the bottom of this slide. I'm going to go ahead and leave this up. I know that we're coming up on 11 o'clock, but if there are any questions, please feel free to go ahead and ask them via the chat, and we'll go ahead and answer them. We'll be here, a little bit past 11 to answer any questions that may come in. But just know that, like I said, the recording will be available sometime this afternoon. Any questions? Well, as always, please provide feedback. That can be done via the registration page. We like to know that what we're doing is a value to the community. We definitely have fun putting together these presentations. Um, but if they're not of value to you, then we want to refocus where we're spending our time. So and the registration page is a way to do that because it allows you the ability to give us a way to contact you if you actually have a question or you know point us in the right direction so that we can provide content that is of value to the community. Okay. So we'll stick around probably for another 10 minutes or so. If any questions come in, we'll go ahead and we'll answer them. Um, as for everyone else, you're welcome to drop off. This is the end of the presentation. As I said, the recording and the slides will be available at www.mcnc.org/cne-webinars sometime this afternoon. Definitely, if you found it of value, go ahead and download them. And in the process, if you're going ahead and doing this yourself, you're following these directions to configure a Pi, and you run into some sort of issue, definitely reach out to us. We're more than happy to help you along. I will tell you, I went through many iterations of this until I finally settled on what I did. Raspberry Pis are an interesting platform. Really, there's a lot that you can do with them, but definitely there is a learning curve there. Okay, especially for me, I am a Red Hat guy, so I'm more familiar with CentOS, Fedora, Red Hat. Debian is somewhat new to me, so definitely figuring out the differences in the commands, especially for doing an update. Upgrade is not intuitive to me. Generally an upgrade means that you're installing a different distribution and not updating the packages that are on the operating system that you're working with. So now I do know also with the Influx DB, there are versions for Mac as well. So you could actually run Influx DB on the Mac. But like I said, for the purposes of this presentation or this particular project, we were trying to find a low cost alternative, which the Raspberry Pi definitely fits that bill, to be able to do persistent monitoring across your network without having to spend a lot of money to do it. Okay, we're going to go ahead and wrap this up as we have no further questions. As I said, definitely fill out the feedback on the registration for us. That would be very helpful to us and hopefully helpful to you guys in the future. Thank you.